Okay, this is the coding for task 1. Then we click run. Okay. Then
Teman-teman.
the LED is light up. Okay, that's all for task 1. Thank you.
This program uses three LED buzzer and a push button. When the button is pressed, the LED lights up by one red, yellow and green and keep repeating as long the button is held. When the button is not pressed, the system runs automatically. The buzzer beep once and the LED blink 3 times when the LED light up in the order green, yellow and white and red twice. Before turning off, this cycle keep repeating. The button simply change the mode between manual LED, sequence the automatic LED with the buzzer button. Okay, mantap.
Assalamualaikum, my name is Asha binti Muhammad Taufik and I will show and explain the simulation in Proteus. For the task 1, I designed a simple circuit in Proteus using Arduino and 3 LEDs. All LEDs are connected to different pins which are pin D2 for red, pin D3 for yellow and pin D4 for green. And then each LED has a 330 ohm resistor to protect it from high current. And after that, all LEDs are connected to ground. The purpose of this circuit is to show how we can control multiple LEDs using Arduino. In the coding, all LEDs were programmed to follow a sequence. First, all LEDs will turn off and then they run one by one from red to yellow and then to green. Later on, they will blink together. The delay function in the code controls the timing for on and off. This shows the basic concept of digital output in microcontroller programming. The circuit in Proteus help us to visualize the real hardware connection before we uploading it into the real Arduino board. This is the simulation for task 1. When we run the circuit, LED will blink from red, yellow, and then green. This will repeat twice, and after that, the LEDs will blink together 2 times. And then they will repeat the same sequence again and again. For the task 2, I extend the circuit a little bit by adding a push button and a buzzer. The LEDs are now connected to pin D5 for red, pin D6 for yellow, and pin D7 for green. The buzzer is connected to pin D30. Meanwhile, the push button is connected to pin D4 with a 10K resistor as the pull-down resistor. The function of button is to give the user input to the Arduino. When the button is not pressed, the circuit follows a normal sequence. The buzzer beeps, all LEDs blink, and then the LEDs run from red to yellow to green. When the button is pressed, the LED change their sequence and run continuously from green to yellow to red. In this coding, if-else statement is used to detect the button state. If the button input is high, and then the LEDs will follow the reverse sequence. Otherwise, the program will run the normal routine. This circuit demonstrates the interaction between input, the push button, and output, which are LEDs and the buzzer. It also shows the program logic can change the behavior of hardware depending on user input.